Okay, we want to talk a little bit about statistics, and this is a very, very brief overview of all the statistics necessary that people use in engineering. But we just want a brief idea. A lot of these concepts you've probably talked about before, but we'll go ahead and talk about them in a little bit with regards to engineering. So the first is a histogram. And if you're not familiar with the histogram, maybe you've heard of a bell curve. It just kind of shows the distribution of the data that you've gotten. So what we've got is basically they have what they sometimes call bins, where you set this kind of range of values, and then basically you count how many times that range of values occurs. So you have kind of frequency. Each bar represents how many times that range of values occurs, right? So, and you follow, a shape as shown here. Okay, we'll talk a little bit about what those look like, but that's what a histogram is. Okay, and we can use it just for visual representation of how the data is distributed and where most data is and things of that nature. So, next thing we want to talk, once we have kind of that visual representation of our data, let's talk a little bit about central tendency, sometimes called average. Now, there are three types of averages. Typically, you're familiar with these: mean, median, mode. But again, what we're trying to do is we're trying to find when we're dealing with like measurements, okay, it's basically where is this typically going to fall? If I take these measurements, if I have these values, okay, where do I expect them to fall? What's the central point of which it falls? Okay, and there are three different ways that we can measure this. Okay, the mean is what most of you are familiar with. Basically, add up all of the values, okay, and divide by the number of values that you have. Okay, that's the arithmetic mean. Okay, now, the thing with mean, again, probably the most standard, is it's subject to changes. If there's a change in one of the values, the mean is going to change as well. Uh, and because of that, uh, if you've got weird, wild changes, extremes, if you will, it can make big changes that don't necessarily represent the average. Okay, so these are best for more symmetric representations, like the top representation we have right here. Okay, and you can see the mean is 100. Okay, which is kind of right in the center of this data. Again, that central tendencies. Now, we'll get more into this skewed diagram here in a little bit, but you can see the mean on this one maybe doesn't represent exactly where most of the values are. We'll talk a little bit about this in a little bit. But again, what you do with the mean is you just add up all the values and divide by the number of values. Now, a median is basically like the middle point, right? Half of the data is above the point, half the data is below that point. If you think about percentiles, this would be like the 50th percentile. Again, 50% is bigger, 50% is smaller. Okay. Because of this, it has less effect of changes in the data, right? So if that data is skewed, like I have in the bottom, or I've got outliers like numbers way, way higher, way, way lower than anything else, um, the mean isn't affected. So the example I always give is oftentimes you hear like median income. Okay, and the reason for that is if you've got a whole group of people hovering around $50,000 annual income, something like that. And then a very, very wealthy person walks in that makes $1 billion a year. Okay. Everybody's at, now the average is maybe 100,000, even though none of those original population have 100,000, but that one value is so large, it's such an extreme that it shifts the mean all the way over. Whereas the median still, you add that one person that's very, very wealthy, that median maybe shifts a little bit, but not nearly to the degree that a mean does. So if you've got skewed data, such as again in this lower one, or data with points way outlier of the other ones, median is sometimes a better uh, thing. And you can see that on a normal distribution, mean and median, they're this is zero point 0.4 off, 101.06 in the top one. But in the bottom one, the mean and median can be almost 10,000 off on this value here. So again, when you've got that skewed data, those outliers, median is oftentimes the better representation of the central tendency. Now, the mode is when it occurs most frequently, and a lot of times in engineering, we don't use the mode very often. This is mainly used when you have like categorical data, like what is your favorite color of a population, right? Red, green, blue, right? It's not numbers across the bottom. It's basically, which one do you like the best? And all you can do is say, well, the most people chose this one. So it's not exactly like a continuous distribution, if you will. It's more discrete in nature, and that's where the central tendency of a mode would come from. Again, we usually look at mean or median, just depending on the type of data that we're looking at in engineering. Okay. Now the next is what we call variability, and that's basically how much dispersion does the data set have. Uh, so if something's got a lower variability, most of that data is going to be very close to one another, more consistent. More higher variability, things will be more distributed, be a little bit more spread out. So if you look at our histograms on the top here, we've got this one. They've got the same mean, however, the distribution is much different, right? Much tightly packed on the plot on the left than the plot on the right. The data is much more spread out on that one, so there's more variation in that. Now, we um, model this. We put a number to, we quantify it using what's called the standard deviation. There's the equation for the standard deviation. Don't worry too much about it. What you really want to know here is what's the typical difference between a data point and the mean? Basically, how confident you can be that the data you're taking is close to what the mean would be. Therefore, generally, the smaller that um, standard deviation, the tighter we are to the mean, the more precise the measurement will be, the more you can feel confident that it's close to the actual value, as opposed to a large standard deviation where things are spread out further away. Okay. Now, the kind of the rule of thumb to think about is with a normal distribution, about 2/3 or 60%, 68% of the values will be plus or minus one standard deviation away from the mean. So most of the data, okay, 2/3 about of the data occurs plus or minus one standard deviation. You can go out further standard deviations and see how that works out. And again, that's for normal data, but it gives you some idea, right? So it's that range of value where you can feel confident that the value is close to the typical or the central tendency that you're looking at. Now, I'll follow this up with how we do this. We typically do it in Excel, and I'll go through some data to show you how we can actually do this in Excel.